Welcome back. In today's video, we are going to look at circle theorem 2. In the previous video, we looked at this theorem, theorem 1, which stated that the angles in a semicircle are always right angles. If you didn't watch it, I encourage you to do so. But for today, we are going to jump right into theorem 2. So for this lesson, we are going to talk about this theorem, which involves the tangent and the radius. We are going to find out a special property that happens when a tangent and a radius meet. So let us jump right into our beloved app. As you can see, we did a great deal of stuff in the previous video. If you didn't watch it, I encourage you to pause this video and look at the video, because you're going to learn a lot. We talked about so much. As you can see, so much is going on in here. So let us clear out that and start with today's lesson. We need a circle, obviously, because this is a circle theorems playlist. This is our circle. So now we need a tangent. Let us add a tangent to this circle. Remember, a tangent is a line that only touches a circle at one point. So let us add, first of all, just a point like so, point C. Then we go below and locate the tangent. Okay, under construction here we have the tangent. So now let us select a point, then we select our circle. So as you can see, this is our tangent. As you can see, no matter how I move it, so when I move it, it represents all the points on the circle. As you can see, this only touches the circle only at one point. It doesn't cut the circle, it only touches the circumference at one point. In this case, this is point C. Okay, so now what is the theorem stating? Let us read the theorem together. A tangent to a circle makes a right angle with the radius at that point. So in this case, we are referring to point C. So at the point where the tangent touches the circle, it makes a right angle with the radius. Okay, as you can see, we are using now the definition and the terms that we learned in the previous videos. The radius, the tangent. My friend, if you haven't watched those videos, I encourage you to do that, because this will make the lesson more fun and interesting and engaging. As you can see, we have the tangent and we have the radius. Let me just change the style so that you can see properly. So that dotted line represents the tangent, then this line CA represents the radius. So as you can see, where the tangent and the radius meet, it's forming an angle, and the definition says that it forms what kind of angle? A right angle. And we said in the previous video, a right angle is simply an angle equal to 90 degrees. So let us measure and prove if the theorem holds true. I'll have a challenge. So let me just appoint an arbitrary point like so, because we need more than 2 points to create an angle. So this is why I've created point D and E to represent the third point. So let us create an angle. 1, 2, 3. There it is. As you can see, these theorems are very useful. This is why in the exam it's very difficult, if not nearly impossible, if not impossible, should I say, to answer these questions without knowing the theorems. So it's very important to know the theorems. As you can see, point A, or should I say angle ACD is equal to 90. So let us see if it holds true here as well. For point A, or should I say for angle ACE. Okay, let me go where it says measure, and let's see if it holds also true for angle AC. For some reason it has measured the outside angle. Let me start like so. As you can see, just like magic here, guys, it has managed to find the angle. As you can see, let me just do this. So as you can see, this is what we are talking about. The tangent and the radius are forming a 90-degree angle where they meet. So this is very wonderful, guys. Let me animate this so that at least we get some fun out of this. As you can see, whichever point I'm going to choose, it's always going to be 90 degrees. Those angles are always going to be 90 degrees, no matter the point I choose. So this is a very useful demonstration of what we are talking about here. As you can see, whether it's a point here, where the tangent meets here, whether the tangent meets at point B, whichever way, it's going to be 90 degrees. I'm going to end this lesson by just giving you a demonstration of how a question in the exam might come. So let me just delete this angle like so. And yeah, we are going to see a scenario. Let us recreate the scenario. Let us go into the minds of the Examination Council of Zambia, ladies and gentlemen, and I will show you how these questions are answered. Imagine we have already been given this angle here, which is angle. Let me just move the points in order to achieve something without a decimal point. This is wonderful, great stuff. So let's say that we are required to find this angle ADC. So how in the world are we going to find angle ADC? We know that this is a triangle, not so. This is a triangle. Let me color it so that you can better see what I'm talking about here. This is wonderful stuff. As you can see, this is a triangle. You can see by the blue fill inside here. This is a triangle. And we are required to find this angle. Let's say we are required to find this angle here. Because the Examination Council of Zambia already knows that, this is 90. So it's very easy. So they try to exaggerate and make things rather complicated. So they will tell you to find this angle here, ADC. So how in the world are you going to find that angle? My friend, if you already know that this is a radius and this is a tangent, of which they are going to clearly state it in the question, in the problem statement. In the question, when you read it, they are going to say that this is a tangent. Okay, because they don't like guesswork. So this is the tangent and this is the radius. So my friends, immediately as you see this, something should click into your mind. There is a rule that applies here. And what's the rule? Where the tangent and the radius meet, they form a 90 degree, a right angle triangle. What is angle? A right angle. In order to find an angle in a triangle, all we need is 2 points. And the rest can be found by just adding the known angles and subtracting their sum from 180, because in a triangle the angles sum up to 180. So this angle plus this angle plus this angle equal 180. So we know that 40 here is the angle for DAC. We also know that the radius and the tangent are meeting to form a 90 here. We already know that this is a 90. So if we had a 90 and a 40 degrees, that will give us 130. Now, since we know that we have the two angles that sum to 130, all we have to is subtract that 130 from 180. So what is 180 minus 130, which is 50. So we have found the angle CDA. Let us prove. This is why I love mathematics. As you can see, boom. Ladies and gentlemen, you owe me a module silver. Okay, you owe me a module silver. This is magic I'm teaching you here. Yeah, so as you can see, this just works like magic. This is how you impress your friends, those that haven't learned this subject. You can make a lot of money from this, my friend. I'm joking, okay? Yeah, so this is what is happening here. So as you can see, we have found that angle just by knowing the property. So thank you so much. If you enjoyed this lesson, make sure to give us a thumbs up subscribe ultimately if you are new to this channel, and see you next time for the next video or the next lesson, where we are going to talk about what we call the isosceles triangle. Thank you and have a nice day.